Till now we have discussed TTT diagram, time temperature transformation diagram of plain carbon steel. By plain carbon we mean that these steels have mainly carbon as the significant alloying addition. But there are steels which are alloy steels, where apart from carbon there are other elements have been deliberately added to alter its properties. So, these steels are called alloy steels. So, let us look at how alloying modifies the TTT diagram. So, here is a example, not of any particular steel, but a schematic one of how what the alloying does. So, to the TTT diagram. So, diagram of alloy steel. First of all, you see that instead of a single node which were there, we now seem to have two noses. So, there are two separate C curves, that is the C curve for pearlite and bainite have been separated. So, this is the first effect of alloying, that they are separate C curves for pearlite and bainite. In the case of plain carbon steel, the C curves for pearlite and bainite so merged that the upper part was for pearlite and the lower part was for bainite, and you had a single node where they met. But now pearlite has its own nose and the bainite has its own nose. So, the first thing is that there are separate C curves for pearlite and bainite. Also, the other effect is that the C curve has been shifted to the right, that is to the higher time side. So, this time for example is much longer than in the plain carbon steel. So, we can say C curves are shifted to the right, that is to higher time scales. That is, formation of pearlite and bainite now becomes sluggish, slower. It takes longer for pearlite and bainite to form in an alloy steel than in a plain carbon steel. This fact is related to what you studied in diffusion, because all the alloying additions, most of the alloying additions, let us note some of them. So, the alloying additions are some common alloying additions are manganese, chromium, molybdenum, nickel, tungsten, etc. So, these alloying additions are substitutional solute for ferrite and cementite. So, substitutional and you have seen that carbon is interstitial solute, and you have also seen in the diffusion chapter that substitutional solute diffuse much slower than interstitial solute. So, because of this slower diffusion of this additional alloying addition, these transformations, both perlite and bainite transformation, become slower and gives you more time at the nose. Also you can see that the suppression of perlite is much more than that of bainite. So, this exposes bainite nose below the perlite nose, and so in the case of alloy steel, often it is possible to produce bainite simply by a continuous cooling. So, if I start with austenite and if I choose a cooling rate which avoids the perlite nose, but enters into the bainite region, by continuous cooling I can produce bainite. So, this is another feature of alloying. Continuous cooling. This was not possible in plain carbon steel. You can see that in the plain carbon steel, since you had a single nose, so there was no way that if I cool slow, I form perlite. If I cool very fast, I form martensite, but there is no way for continuous cooling to produce bainite. Of course, I can have an intermediate cool. Some of you may be thinking that what will happen if I cool at an intermediate rate like this. In this kind of intermediate cooling also, you can have just like we have for a start, we have C curve for a start and finish, you can have C curve for different amounts of transformation. So, this will be, let us say, a 50% transformation, C curve for 50% transformation, and this black curve is touching the 50% transformation and the transformation is happening above the nose. So, this black curve will still produce 50% perlite. Remaining 50% is austenite and will not transform to bainite on continuous cooling, but will be transformed to martensite as it crosses MS and MF. So, the microstructure produced here will be perlite plus bainite, perlite plus martensite, and there will be no bainite. So, bainite cannot be produced on continuous cooling in plain carbon steel, but here you are seeing that in alloy steel bainite can be produced by continuous cooling. So, these features of alloying and its effect on the TTT diagram should be kept in mind.